A fundamental issue in microbiology is that in many instances, we cannot study microbes without destroying them. Finding a solution to this problem will allow us to ascertain the true characteristics of cells, which has not been possible until now. Research on microbes has involved the use of methods that tampered with cells in one way or another, such as the use of dyes, gene transfer, or extraction of their constituents.
つまり、非破壊的、非侵襲的な検査というのがこれまでは難しかったということかと思います。
This led us to focus on the inherent fluorescence, or autofluorescence of the cells themselves. Autofluorescence is emitted when the variety of organelles and chemicals inside the cell absorb light, such as UV light. A research group at the University of Tsukuba has been investigating ways to make use of microscopes to look at this autofluorescence in analyzing cells.
細胞を壊さずに、その性質や種類を知ることができれば、生きた細胞ならではの情報というのを失わずに細胞を研究することができる。生きた細胞ならではの情報というのは、例えばその細胞がその後どうなるのか、その後どういう物質を作るのか、他にどんな細胞と相互作用するのかといった時間的なデータがわかる。こういったところは非常に大きい部分だと思います。
This research brought together the knowledge of microbiology, engineering, and applied mathematics. Based on the use of a confocal microscope, a laser beam is shined onto the sample to trigger inherent fluorescence, which is then observed. A system was developed to carry out screening for each characteristic. This microscope does not require the use of dyes, gene transfers, and so on, allowing the obtaining of images like this through the observing of inherent fluorescence alone. However, this by itself does not allow ascertainment of whether the light is coming from inside each individual cell or from substances in the extracellular matrix released by the cells.
これまで細胞の種類ですとか細胞の生理状態といったものを調べるのは非常に手間のかかる作業でした。これがまず簡単になれば良いなというのが一つですし、あるいは、我々が今微生物というものをイメージすると均一な細胞の集団のように思われるんですけども、実は細胞の集団の中にも細胞一つ一つに個性というものがありまして、こういった個性を簡単に検出して評価する技術というのはこれまでにありませんでした。
This led to the use of image analyzing technology using AI. First, the outlines of cells are identified from the captured images. Then fluorescence from extracellular substances is deleted from the data. Next, the autofluorescence is extracted exhaustively from the luminescence information contained within the outlines of the cells. Then, machine learning of the fluorescence profile of each cell enables identification of its type. High-speed image processing technology using AI will carry out this work instantaneously. This will enable the simultaneous measuring of multiple cells. The technology will not only allow identification of the type of cell, but also their individuality and the tracking of changes in the physical state of individual cells over time. Until now, all cells and bacteria were considered to be the same, but we will now be able to focus on their specific differences as they interact with one another in living their individual lives. As multipotent stem cells, such as iPS cells, draw closer to being put to practical use, there has been a growing need for mass cultivation of cells throughout the world. This technology is on the verge of offering a new way of evaluating the quality of mass-cultivated cells and allowing the selection of good quality ones.
私たちの方法を用いることで微生物の個性や性格といったより深いことを簡単に知ることができるようになります。我々はこの情報を生かして人間社会と微生物の関わりをより深め、より理解していきたい。そういうふうに考えております。
A new world is on the verge of being discovered through innovative technologies that have been spun off from the science fusing microbiology, engineering, and applied mathematics in pursuit of ascertaining the true characteristics of cells.